Have you ever wondered how great software gets planned out before a single line of code is ever written? Well, today we're going to pull back the curtain on one of the key tools for that exact job, the use case diagram.
So, let's kick things off with a question. What on earth do a house blueprint and a really great piece of software have in common? Now, it might seem like a weird comparison, but trust me, the answer is central to everything we're talking about today.
The answer is, they both start with a simple, visual plan that everyone involved can understand. Think about it. The architect, the builder, the client who's going to live in the house, they're all looking at the very same blueprint. In the software world, we need that exact same kind of shared understanding.
And that's exactly where the use case diagram comes in. It's basically a picture, a model, of what a system is supposed to do. Now, the most important thing to get your head around is this. It focuses on the what, not the how. We're talking high-level functions here, not getting bogged down in the weeds of code or servers.
So at the end of the day, use case diagrams are really a communication tool. They're like a bridge that connects the technical team with all the stakeholders, the managers, the clients, making sure everyone is on the exact same page about what the system will actually do.
Okay, so how do we actually build one of these things? Well, here's the great news. It's surprisingly simple. We only need to learn 4 core components.
Yep, just 4. That's it. Let's break them down one by one.
First up is the system itself. This is simply the thing we're building. We represent it with a big rectangle called the system boundary. Think of it like a sandbox. Everything the system does has to happen inside this box.
Second, we have actors. These are the roles that are going to interact with our system. And listen, an actor isn't always a person. It could be another piece of hardware or a completely different software system. The key rule is they always exist outside of that system boundary we just drew.
Third on our list are the use cases. These are the high-level goals or activities that an actor wants to achieve with the system. We draw them as ovals inside the system boundary, and we give them really clear action-oriented names, like buy a course or withdraw money.
And finally, number 4, relationships. Now, don't let the name sound complicated. These are just the lines that connect an actor to a use case. That's it. They just show who participates in which activity.
All right, enough with the theory, right? Let's make this practical. We are going to build a simple diagram right now for a basic online learning management system.
Okay, first things first, we draw our box, our system boundary. This is the container for all the functionality of our new learning management system.
Next up, who's going to be interacting with this thing? Let's add our actors outside the box. We'll have a guest who isn't logged in and a registered user who is.
So what do these actors want to do? Let's pop the use cases, those ovals, inside our system. A guest probably needs to be able to search item, and a registered user, well, they should be able to buy a course.
And for the final step, we just connect the dots. We draw a line from the guest to search item and another from the registered user to buy a course. And there you have it, a simple, clear blueprint of our system's core functions.
Okay, so you've absolutely mastered the basics. Now, let's level up. We can add a lot more detail and logic to our diagrams using 2 special types of relationships, include and extend.
Now, the difference between these two is simple, but it is so important. An X-include relationship is for mandatory behavior, something that absolutely must happen. In contrast, an X-extend relationship is for optional behavior, something that only might happen, but only under specific conditions.
Let's look a little closer at include. It's perfect for functionality that's shared across a bunch of different use cases. Think about an ATM. Whether you want to withdraw money, transfer money, or check balance, you first have to be authenticated. So all 3 of those use cases would include the validate user use case. It's a great way to avoid repetition and keep things clean.
On the other hand, extend is for those optional paths. The main use case can complete perfectly fine on its own. A classic example is enroll in university. For most students, that's the whole process. But if the student is a foreign student, then the process is extended to include an extra step, perform visa check. You see, it's a conditional fork in the road.
These diagrams aren't just a bunch of technical drawings. They are really the table of contents for a much richer story, the user's actual step-by-step interaction with the system.
Think of it this way. If the use case diagram is the map showing you your destination, then the use case scenario provides the detailed turn-by-turn directions to actually get you there.
And here's what that looks like in practice. For the withdraw money use case, the scenario spells out that exact back-and-forth conversation. The system does something, the user responds, the system does something else. This is what we call the main success scenario, or sometimes the happy path, where everything goes perfectly as planned.
And that is really the big takeaway today. Use case diagrams are not just abstract tools for engineers. They are fundamentally a storytelling device. They tell the simple, clear story of how a person, or maybe another system, is going to achieve a specific goal.
So I'll leave you with this little challenge. The next time you use any app on your phone, whether you're ordering food or checking your bank balance, just take a moment. Can you picture the simple blueprint behind it? The actors, the use cases, the lines connecting them? Because that's very likely how the whole thing started, as a simple plan that everyone could look at and understand.
Welcome back to the Deep Dive, your shortcut to being well-informed.
Great to be here.
Today, we're diving into a really foundational tool in software engineering. It's use case diagrams.
Essential stuff.
Yeah, we've got this fantastic document, Lecture 4, Use Case Diagrams, as our guide. And our mission really is to take these, sometimes complex concepts and make them clear. Actionable knowledge.
Absolutely.
This deep dive, it's going to show how these diagrams simplify what can be a pretty daunting task, defining what a software system actually does.
Right.
And that's for everyone involved, developers, end users, management, everyone. It's kind of a shortcut to understanding the what of the software without getting totally lost in the how.
And understanding that what is just absolutely critical. Imagine trying to build a house without a blueprint.
Right. Yeah.
No idea what rooms you need, where the doors go. It'd be chaos.
Definitely.
These graphical notations like use case diagrams, UCDs, they are that blueprint for software. And they're not just for the engineers. That's the key. They are a vital communication tool. They make sure all the stakeholders, management, clients, the development teams, share a clear, unified vision.
A shared vision from the start.
Exactly. From day one.
Yeah.
Without this, projects can run into really serious miscommunications, costly reworks down the line.
Okay, so let's unpack this core idea then. A use case diagram. It's a fundamental part of what's called requirement specification in software engineering. And its job, specifically, is capturing the functional requirements.
Yeah, what the system does.
Exactly. Think of it like a high-level visual map. What does the system offer its users? Its main benefit is showing that proposed functionality graphically.
Usually, yeah.
Helps demonstrate the high-level behavior to clients, maybe,
Right.
without getting bogged down in all the technical stuff.
Precisely. And the power there is how well UCDs communicate with the non-technical people.
Right. The stakeholders, customers, management.
Yeah. Communicating what a system will actually achieve when it's done. And this is the crucial distinction we keep mentioning. UCDs focus purely on what the system will do.
Not how.
Not how it'll do it. That focus keeps discussions strategic. It avoids information overload, makes sure everyone understands the user's goals first.
That makes sense.
And while we're focusing on UCDs today, it's probably worth mentioning there are other graphical tools too, like activity diagrams. They kind of complement UCDs by showing how those use cases actually unfold step by step.
Okay, good point. But sticking with UCDs for now, if we want to build one of these diagrams, we need the building blocks, right?
Yeah, the basic components.
Our source material highlights 4 fundamental ones. First, you've got the system itself, sort of the boundary of what we're actually building.
The box, basically.
Yeah. Then the actors. These are the external roles interacting with that system.
Outside the box.
Right. Next are the use cases. These are the high-level activities or goals the system supports, what people do with it.
The functions.
And finally, the relationships or links. These show how actors and use cases connect, and sometimes how use cases connect to each other.
And each of those components plays a really distinct, essential role. You need all 4 to get that complete picture of the system's intended behavior.
So it's not just a list. They all work together.
Exactly. The system defines the scope, right? Actors define who or what interacts from the outside. Use cases define the specific tasks or value delivered. And relationships then tie it all together, showing the interactions and dependencies.
Okay.
If you miss one, you've got an incomplete understanding. Simple as that.
All right, let's dive deeper into each one then. First up, the system and the system boundary.
Okay.
The system is, well, simply put, whatever performs the functions we're talking about. But just as important is that system boundary. It's usually shown as a box or a line, and it conceptually separates what's inside our software from the external actors interacting with it.
It's that clear line. This is us, that's them.
Yeah.
Demarcation of responsibility.
Got it. Okay, next. Actors.
The stick figures.
Yeah, the stick figures. They're external entities that interact with the system. And here's an important point our material makes. Actors represent roles.
Roles, not specific people.
Exactly. So an actor could be a human user, like a guest or a receptionist in a hotel system.
Sure.
But it could also be external hardware, or even another software system, like a billing system, maybe.
Right. Anything outside that boundary that talks to our system.
And the stick figure notation is great because it's simple, universal, tells you external entity immediately.
No explanation needed.
So, for example, in that hotel management system, the source suggests actors like guest, receptionist, housekeeping staff, and maybe that external billing system, all roles outside our specific hotel system, but needing to interact with it.
Makes sense.
Okay, that brings us to the use cases themselves, represented by ovals.
The ovals, right.
At its core, a use case is simply a goal an actor wants to achieve by using our system.
A unit of value.
Yeah, like reserve a room or check-in guest. It's that single, complete interaction.
And the naming convention helps there.
Right, the verb, noun, phrase thing. Verb and noun keeps it action-oriented.
Book room, process payment, clear goals.
But what's a common pitfall when teams first try to define these? Is it easy to get wrong?
Oh, definitely. A big one is making them too granular. Too small.
Okay.
You want a use case to deliver some tangible value to the actor, right? If you break it down into things like enter name, enter address, that's usually too low level.
Right, those are just steps.
Exactly. Register guest would likely be a better use case because that encompasses all those smaller steps and delivers a complete result.
Okay, so how do you identify them properly?
Well, the source gives some good questions to ask for each actor, like what are the primary tasks they want the system to perform for them? Will they need to create data, store it, change it, remove it, or just read it?
Oh, okay.
Will they need to tell the system about subtle external changes? Or does the system need to tell them about certain things?
Like notifications.
Yeah. And maybe even, will they perform system startup or shutdown? Asking those questions helps surface the real goals.
So for our hotel system example, using those questions, we might get use cases like check-in guest, book room, process payment, maybe clean room for housekeeping.
Exactly. Those feel like complete, valuable interactions.
Okay. And the final component was relationships, or links.
The connections.
These show how actors get involved in use cases and also how use cases might relate to each other. And there are three main categories here.
Yeah, broadly.
Yeah.
Actor to use case, actor to actor, and use case to use case.
Okay.
And these relationships are super important. They go beyond just listing the parts. They show the complexity, the interdependencies within the system.
How it all works together.
Yeah. They show how information flows, maybe how decisions are made, where potential tricky spots might be. Understanding these connections is key to grasping the system's full scope. It moves it from a static picture to something more dynamic.
All right, let's get into the details of those relationships then, starting with actor to use case relationships.
Okay.
The main one here is called association. Simple, solid line.
Pretty straightforward.
Yeah, it just indicates that an actor participates in or communicates with a specific use case.
Next, the stick figure to the oval.
Exactly. So for our hotel system, you'd draw a line connecting the guest actor to the book room use case.
Makes sense.
And the receptionist actor to check-in guest, maybe the billing system actor to process payment. It's that direct line of interaction.
Clear enough.
Now, actor-to-actor relationships. This one, especially generalization, I found really interesting. It draws from object-oriented programming concepts, right?
It does, yeah. And it's incredibly useful for making the diagram efficient, especially when you have different types of users with overlapping responsibilities.
So how does it work?
Well, generalization means a child actor, let's say, inherits all the characteristics and behavior of a parent actor.
Okay, inherits. Like permissions.
Permissions, functions, yeah. And the child can then add new behaviors, modify existing ones, or even ignore some inherited ones if needed.
Huh. Can you give an example?
Sure, think about a public library system. You might have a general staff actor.
Okay.
Then you could have a more specific librarian actor. The librarian actor could generalize from staff.
Meaning
the librarian automatically gets all the basic functions any staff member can do, maybe check books in, check them out. But then the librarian role adds specific librarian-only tasks, like maybe cataloging new books or managing fines.
Ah, so it shows the librarian is a type of staff member, but with extra stuff.
Exactly. It
Right.
efficiently shows that relationship.
Yeah.
And it naturally leads you to ask, like the source material prompts, who has the most rights in the system?
Right. Often the more specialized child actor, I guess.
Usually, yeah.
Yeah.
Reflecting maybe higher permissions or more responsibilities.
Yeah.
It's a neat way to model those hierarchies.
Okay, cool. Now moving on to the third category, use case to use case relationships. These seem crucial for structuring the diagram and avoiding repetition.
Absolutely. There are three main types here we need to cover. Include, extend, and generalization again, but between use cases this time.
Right. Let's start with the include relationship. What's that about?
Okay, include is used when one base use case explicitly incorporates the behavior of another use case. It's like saying doing A always involves doing B.
Always involves.
A key thing is the included use case B, in this example, never really stands alone. It only happens as part of some larger base use case that includes it.
And why use it?
The main benefit is avoiding repetition. If you have some common behavior that's part of multiple use cases, you put that common behavior into its own separate use case and then just include it wherever it's needed.
Ah, so you only describe it once.
Exactly. Saves a lot of time and ensures consistency. A classic example is like a withdraw money use case at an ATM.
Okay.
That almost certainly includes a validated user use case, right?
Yeah.
You always have to validate the user first.
Sure. Key eye entry, card check.
Yeah. And you don't want to write out those validation steps every single time you describe withdrawing money or transferring funds or checking balance. You just include validate user.
Got it. Makes sense. The source also had an LMS example.
Right, a learning management system.
Yeah.
If a guest wants to attend workshops, they must first include the register use case. Registration is common. It's mandatory for attending, so you include it.
So include means mandatory common behavior.
Mandatory and part of the main flow, yes. A common mistake beginners make is confusing. Include with the next one. Extend. Remember, include is for stuff that always happens as part of the bigger task.
Okay, so what about extend relationship then? How is that different?
Extend is a bit more subtle. Here, a base use case implicitly incorporates behavior from another use case, but only at specific points called extension points, and only under certain conditions.
Implicitly.
A key difference is that the base use case can stand alone. It can complete successfully without the extending behavior ever happening.
Ah, so it's optional behavior.
Exactly. Think of it as B is optional behavior that might happen during A if certain conditions are met.
Can you give an example?
Sure. Imagine an enrolling university use case.
Okay.
That use case might extend to include a perform visa check use case, but only if the student is a foreign student. There'd be an extension point, maybe called foreign student check.
So the visa check is optional, only triggered for some students.
Right. The main enrollment can complete without it for domestic students. Another one from the source, I think, was a library system.
Yeah.
Borrow book could extend to calculate fine, but only if the book being returned is overdue.
Ah, okay. Conditional.
Conditional optional behavior triggered at a specific point.
Okay.
That's extend. The base use case is perfectly fine on its own. The extension adds extra steps under specific circumstances.
So include is mandatory, always happens. Extend is optional, conditional.
You got it. That's the core difference.
Okay. And the third use case to use case relationship is generalization again.
Yes, similar concept to actor generalization, but applied to use cases. A child use case inherits the behavior and meaning of the parent use case.
Inherits behavior.
Yeah, and the child can then add to or override parts of that parent behavior. It's good for managing variations of a core task.
How so?
Well, the source had an example from a student enrollment system. Maybe there's a general use case like search for postgraduate programs.
Okay.
That could be generalized into two child use cases. Search research programs and search taught programs.
Ah, so they both share the basic search function.
Exactly, inherited from the parent. But each child use case might then add specific steps or criteria relevant only to research programs or taught programs. It shows they are specialized types of searching.
I see. That helps organize variations.
It does. It keeps the common stuff in the parent and highlights the specific differences in the children.
Okay, so let's quickly recap those relationships because they seem really key.
Definitely. So associations are just the basic links showing an actor participates in a use case.
Actor to use case. Simple line.
Right. Actor generalization helps model user hierarchies efficiently, like librarian is a type of staff.
Parent-child for actors.
Then, for use case to use case. Include is for common, mandatory behavior pulled out to avoid repetition, part of the main flow.
Always happens.
Extend is for optional conditional behavior that adds functionality to a base use case only if certain conditions are met.
Might happen.
And use case generalization shows specialized versions of a broader use case, inheriting common behavior, but adding specific variations.
Parent-child for use cases.
Exactly. Together, these give you a really powerful toolkit for modeling how a system should behave clearly and efficiently. It really lays the groundwork for the more detailed design later.
Okay, that makes a lot of sense. But, a diagram is great, but it's still just a static picture.
True. It shows the what and the connections, but not the how in terms of flow.
Right. So to really bring these use cases to life, understand the dynamic flow, we need to talk about use case scenarios.
Yes, the narrative part.
What exactly is a scenario in this context?
Basically, it's the step-by-step story. A formal description of the flow of events that happens when one instance of a use case is executed.
Like telling the story of booking a room.
Exactly. Yeah. And usually you have a main scenario that's the happy path.
Happy path.
Yeah, when everything goes smoothly, according to plan, leading straight to the successful outcome. No errors, no exceptions.
Okay. But things don't always go smoothly.
Precisely. So you also need other scenarios or alternative flows or extensions. These describe what happens when variations or exceptions occur. Maybe the user enters invalid data. Maybe a system resource isn't available.
Stuff that leads to different outcomes or requires error handling.
Right. A good scenario description needs to cover a few things. When and how the use case starts and ends, all the interactions between the actor and the system, any objects or data exchanged, the basic flow, happy path, and then all those alternative or exceptional flows.
That sounds like a lot of detail to capture. How do you document that consistently?
That's where having a clear template is invaluable. Our source material provides a really good use case sample template.
Okay. What's in it?
It captures everything needed. Key fields like, obviously, the use case ID and name, the goal, what it's trying to achieve, preconditions, what must be true before the use case can even start.
Like being logged in.
Exactly. Then postconditions, what will be true after it successfully completes.
Like money withdrawn, receipt issued.
Right. It lists the primary actor, the trigger that initiates the use case, and then the really detailed parts. The main success scenario steps, any extensions, those alternative paths we talked about, and often a section for open issues things still needing clarification.
And how are the steps usually written?
Typically in a kind of back and forth format. Like 1, system does X. 2, user does Y. 3, system does Z. Clearly showing the interaction.
Okay, that sounds thorough.
It is. This level of detail is crucial for developers, but also for testing and for catching edge cases early.
Let's walk through that example from the source then. The use case specification template for withdraw money at an ATM.
Sure.
Okay, it says priority 5, so high importance, precondition, user has logged into ATM. Makes sense.
Yep, got to be logged in first.
Post-condition. User has withdrawn money and received a receipt. That's the successful outcome. Primary actor. Bank customer. Trigger. User has chosen to withdraw money from the menu.
All clear so far.
Now, the main scenario, steps. Let's see. 1, system displays account types. 2, user chooses account type. 3, system asks for the amount. 4, user enters the amount. 5, system debits the account, dispenses the cash. 6, user takes the cash. 7, system prints and gives the receipt. 8, user takes the receipt. 9, system shows a closing message, gives back the card. 10, system goes back to the welcome screen. 11, user takes the card.
See that back and forth. System, user. Very clear flow. That's the happy path.
Right. But what about when things go wrong, those extensions?
Yes. The example is 1. It's step 5 when the system tries to debit the account if there are insufficient funds. Then the system notifies the user, maybe shows the current balance, and exits that withdraw option. It doesn't dispense cash.
Okay. That's a critical alternative path.
Absolutely. And the template also notes open issues. Things still undecided. Like, should the system ask if the user wants to see the balance before asking for the amount?
Questions for the stakeholders or designers.
Exactly. This template forces you to think through everything.
Okay, let's try to nail this with one more example. The source mentions Activity 08 borrowing a book from a library.
Right.
It describes the sort of manual process first. Member identifies themselves, indicates the books they want. System checks conditions. Is it reference only? Have they hit their borrowing limit?
Standard library checks.
If it's okay, books are loaned, records updated. How would that look in our scenario template?
Okay, let's apply the template structure. We'd have the use case name, borrow a book. Preconditions might be user is a valid library member, user is logged into the system. Postcondition. Book is loaned to user, loan record is updated, primary actor, library member, trigger, member indicates desire to borrow a book.
Got it. Now the main scenario steps.
Could look something like this. 1, user logs into the system, maybe scans library card. 2, user scans the ISBN of the book. 3, system checks the validity of the request. Is the book borrowable? 4, system shows a summary like, you are borrowing book title due back date. 5, user confirms the request. 6, system records the loan and displays a confirmation message. That's the happy path. Book borrowed successfully.
Okay, makes sense. Now the extensions, what could go wrong?
Plenty. At step 1, login. Maybe the login details are invalid. System notifies, exits. Or maybe their membership has expired. System notifies, exits. At step 2, scan ISBN. Maybe the system can't read the barcode. You could ask the user to enter it manually. At step 3, checking validity. What if the book is marked reference only? System notifies, exits the process for that book. Or what if the user has already borrowed the maximum number of books allowed? System notifies, exits. At step 5, confirmation, the user might look at the summary and decide, actually no, and cancel the request. System exits.
Wow, okay. Listing those extensions really makes you think about all the possibilities.
It does. This systematic approach, capturing both the happy path and all those unhappy paths or alternative flows, is what makes scenarios so valuable. It ensures developers account for these things and stakeholders understand how the system will handle exceptions. It's like, planning a road trip.
Yeah.
You plan the main route, but you also think about contingency plans. What if there's a detour, bad weather, flat tire? You need to know how you'll handle it. Scenarios do that for software features.
What an incredible deep dive that was. It really feels like we've seen how use case diagrams, especially when paired with these detailed scenarios, are just genuinely powerful tools.
They really are.
They take potentially complex software ideas and simplify them, make them understandable for everyone involved. It clarifies that crucial what of the system.
If that communication bridge.
Exactly. A critical tool for clear communication, ensuring the final product actually hits the mark.
So what does this all mean for you listening in? I'd really encourage you to think about how these diagrams, these ideas, might apply to systems you use every day.
Like what?
Oh, anything. That shopping app on your phone, your online banking website, maybe even how your smart home devices work. Take any interaction you have with technology, even one that seems really simple, like ordering a coffee on an app.
Okay.
Now, try to think. How many hidden use cases and actors are really at play behind that single action? You tap order, but what's happening? There's probably select item, customize order, process payment, notify barista, update loyalty points.
Wow, yeah. Lots going on.
And what are relationships? Are there essential include steps, like validating your payment method? Are there extend possibilities, like adding a special offer only if you meet certain conditions? Thinking this way, using this framework, it isn't just for engineers. It can genuinely help you see the world of software with new, more analytical eyes.
That's a fantastic thought to end on, seeing the hidden structure beneath the surface. Well, thank you for joining us on this deep dive into use case diagrams. Keep exploring, keep questioning those systems you use.
Absolutely.
And we'll see you next time on The Deep Dive.